Okay, so this is the screencast for your assignment 2 on balancing equation, page 3 and 4. Okay, so let's try balancing the equation 1a. Okay, I'm going to do this one question at a time, so just follow me. Okay, let's look at 1a. On the left hand side, there are 2 hydrogen, 2 chlorine. Right side, there's 1 hydrogen, 1 chlorine. So very simple, I just need to times 2. 1b, there's 2 hydrogen, 2 oxygen on the left hand side. Then there's 2 hydrogen on the right hand side. Only oxygen is not balanced. So let's try balancing oxygen by putting a 2 on the right hand side. Okay, after that, oxygens are balanced. Hydrogen now has 4 on the right hand side and 2 on the left hand side. So times 2 hydrogen to balance it to 4. 1c, Fe plus iron plus water give iron 3O4 plus H2. Now, this may be a bit strange to you, but let's just balance based on the number of oxygen and iron atoms. Okay, first, let's try balancing the iron first. I have 3 on the right hand side, only 1 on the left hand side. So times 3. Then for oxygen, there's 4 on the right hand side, only 1 on the left side. So let's times 4. Then I'm left with 8 hydrogen on the left hand side, but only 2 on the right hand side. So I times 4. Okay. 1D, Na2O2 with H2O. I think this is the difficult one. Okay, H2O, NaOH, and oxygen gas. So how do I do this question? First, I think the easiest one to balance will be your sodium. Okay, 2 sodium on both sides. So with 2 sodiums and 2 sodiums on both sides, then let's look at the hydrogen. Hydrogen, there's 2 here. There's also 2 here. Okay, so hydrogen is balanced. Let's look at oxygen. On the left hand side, I have 3 oxygen. On the right hand side, I have 1, 2, 3, 4. 4 oxygen. Okay, so how do I balance the oxygen then? Okay, if I take a look on the usually when you are stuck despite following the steps, you can only do trial and error. Okay, what I do is I usually balance the things that I've balanced before, multiplying it by a multiple of 2. Okay, let's try. Okay, so just now that one was 2, right? If I multiply it to 4 and this is 2, let's see how many hydrogen we need. Okay, there will be 4 sodium, okay, 4 hydrogen, so times 2 hydrogen. Okay, total number of oxygen is 2 times 2, so 4 oxygen plus 2 oxygen here. So I have 6 oxygen in total. On the right hand side, I have 4 here, I have 2 here. So I also have 6 oxygen. So correct, balance already. Remove all these small number. Okay, next, let's look at our aluminium plus iron 2 oxide. Now how can I tell that this is iron 2 oxide? Okay. Oxygen is O2 minus, iron is 2 plus. Okay, you know that is 2 plus because it's 1:1 ratio here. So if O is O2 minus, iron must be Fe2 plus. Okay, let's see why it's not balanced yet. Okay, you can see that obviously aluminium is not balanced. Put a 2 here. Okay, oxygen is also not balanced. There's 3 on the right hand side and only 1 on the left hand side. Times 3. Then there will be 3 iron. There's only 1 on the right hand side. Let's remedy that by putting a 3. Last check, is everything balanced? Yes, it is. Okay. 1F, magnesium plus nitrogen gas gives you magnesium nitrite. So there's 3 magnesium and there's 2 nitrogen. Oh, so balanced already. Okay, G, aluminium plus hydrochloric acid gives us aluminium chloride and hydrogen gas. So let's see why it's not balanced here. Aluminium is balanced already. Chlorine, I need to have 3 of it here. Now, but you know that your hydrogen is must always be an even number because it's always a multiple of 2 on the right hand side. So since then it means that your hydrogen can't be 3 here, it must be in a multiple of 3 and 2. So let's just multiply everything by 2. Then there will be 3 hydrogen. Okay. Next, C2H2 plus O2. Oh, I think this is also a difficult one that student couldn't do just now. Okay, so how can I balance this equation? There's 2 carbon on the left hand side and only 1 on the right hand side. So let's just times 2 first. Okay, next, you see that the H2 is balanced already. But now we run into a problem. For oxygen, right, on the left hand side, there's only 2. On the right hand side, I have 5. Now note that it can't be an odd number again because the only species containing oxygen is on the left hand side is oxygen gas, which means that it must also, again, the number of oxygen atoms must always be even. So how do I make it even? Note that on the right hand side, I need to make this a multiple of 2. Okay, so let me just try multiplying it by 2, which means that I need 4 hydrogen. So times 2 here. So here, I need to change to 4. Okay, let's count the number of oxygen again on the right hand side. I have 8 here and 2 here. So total there's 10 oxygen. Okay, so on the left hand side, I just need 2 times 5. Okay, next, let's look at question I. Silicon dioxide plus hydrogen fluoride gives us silicon fluoride and water. So how to balance? Let's balance F first. Okay, F, there's 4 on the right hand side. So I times 4. Okay, that means that there's 4 hydrogen on the left hand side. On the right hand side, there's 2. So times 2. Then it should be balanced already. Okay, next, J. The J looks like I. Okay, J, aluminium plus HCl, this AlCl3. It's the same question. Okay. It's the same question as G. Okay. Now K. Let's look at the number of. Okay, remember that I taught you all how to balance by the polyatomic ions before. Okay, so you see here that there's a sulfate ion. Here, there's also sulfate ions. But there's 3 sulfate ions. So to balance the number of sulfate ions, I can multiply these by 3. Gallium is balanced already. There's 2 on each side. Let's look at oxygen. On the left hand side, okay, my hydrogen is not balanced yet. Let's look at hydrogen first. Okay, so there's 6 hydrogen on the left hand side. On the right hand side, there's only 2. So let's multiply by 3. Okay, let's count the number of oxygen. There's 3 oxygen here. Okay, let me write it the other way. There's 3 oxygen here. Okay, then there's 3 times 4, so 12 oxygen here. Total there will be 15. Okay, on the right hand side, there's 3 times 4 here, so 12 also. And then here there's 3, so total there's 15 oxygen. Okay, so everything is balanced already. Next, let's look at Hi plus sulfuric acid. Okay, then we have all these. Now, can we spot something that only appears once? Okay, sulfur only appears once. Iodine also only appears once. So let's try balancing iodine first. Okay, iodine, there's 2 on the right hand side, so I put a 2 on the left hand side. Okay, so iodine is balanced already. Let's look at oxygen. Okay, oxygen on the left hand side, there's 4. On the right hand side, there's only 1. So let's times 4. Okay, times 4. Then let's calculate the number of hydrogen. You can see that hydrogen obviously cannot make it. Okay, hydrogen on the right hand side, there's so many. Okay, there's 2, 4, 6, 8, 10, 10 on the right hand side. On the left hand side, there's only what, 4. Okay, so little. So what can I do to remedy this? Now, there are two ways for me to change the number of hydrogen on the left hand side. Okay, I can either increase this Hi or I can increase my H2SO4. Which one do you think is easier to increase? Okay, it's actually easier to increase our Hi because in doing so, I'm only affecting one other element, I. And I is easy to balance because there's only one species that has I on the right hand side. If I choose to balance hydrogen by increasing H2SO4, I need to both increase this as well as this. So it will be a never-ending loop of trying to balance it. Okay, so what we'll do now is, let's try and balance the number of hydrogen. On the right hand side, I have 10. The left hand side, I have 2 on H2SO4. So here I need 8 to make it 10. Okay, then how can I balance the number of iodine? On the left hand side, I have 8. So on the right hand side, I times 4. Okay, this will be your balance equation. Okay, I think this is also quite hard. Now, I also got questions on M. So, let's see, copper is balanced already on left hand and right hand side. Then for nitrate, now remember I teach you can balance by polyatomic ions. I can't do that for this one because see that there's another nitrogen containing species and it must have come from our nitrate because there's nothing else containing nitrogen on the left hand side. So if we can't do that, let's try another method. Okay, copper is balanced already. Hydrogen, not yet. So let me put a 2 here. Okay, so oxygen and nitrogen are obviously not balanced. So what can I do? Again, this is kind of try and error time based on your gut feeling. Okay, so let me just try 4. Okay, if it's 4, then it's 4 hydrogen on the left hand side, 2 water. Okay, how many oxygen do I have on the right hand side? 2 plus 2 plus 2 times 3, 6. So total I have 10 on the, 2, 2, 2. Yeah, I have 10 on the right hand side. Then there's 12 here. So to balance the number of oxygen, the nitrogen also not balanced. Okay, the number of nitrogens on the left hand side, there's 4. On the right hand side, there is 3. So let me balance it by putting a 2 here first. Then I'll up this to 4. So you can see that actually it is already balanced. Now this one, the first part, I think I went through in the previous video, so I won't go through A. Let's look at B. Neutralization of sulfuric acid with sodium oxide to produce sodium sulfate and water. So again, the first step is to write down the correct formula. H2SO4 plus Na2O to give us Na2SO4 and water. Okay, let's try balancing. Sulfate by sulfate is balanced. Nitrogen, there's 2 here, there. Sodium, there's 2 here, sodium, there's 2 there. Okay, hydrogen, there's 2 here, hydrogen 2 here, oxygen, oxygen. Everything is balanced. Okay, next, 2C, reaction of zinc carbonate with hydrochloric acid to produce zinc chloride, carbon dioxide gas, and water. So zinc carbonate, let's think of what's the formula. Zn2 plus with CO3 2 minus, so it's ZnCO3. Combining it with HCl, hydrochloric acid, Okay, I don't write the state symbols, if not you'll confuse. To give us zinc chloride, Zn is 2 plus, Cl is 1 minus, so Zn Cl 2. And carbon dioxide and water. Okay, so let's see. What must we balance first? Zinc is balanced already. Let's look at our chloride. So on the left hand side, there's 1. On the right hand side, there's 2. Balance. Hydrogen balanced already. Oxygen. 3 on the left hand side. On the right hand side, there's 2 from carbon dioxide, 1 from water. 3 also. So everything balanced. Yay. Question 2D. Reaction of aluminium with nitric acid to produce aluminium nitrate and hydrogen gas. Aluminium with nitric acid give us aluminium. Aluminium is Al3 plus. Oh, I forgot to mention, so remember that for metals, the formula is just simply the chemical symbol itself. No need charge, no need anything. Okay, so aluminium nitrate, Al3 plus NO3 1 minus, so AlNO3 3 plus hydrogen gas. Let's see, what do I need to balance? Okay, there's 3 nitrate here, 1 nitrate here, so I put a 3 in front. Then I notice that here, hydrogen gas, again, must always be an even number. So let's try making it even by changing it to 6, and this one times 2 instead. So I need 2 aluminium. Now, how many hydrogen do I need on the left hand side? I have 6. So on the right hand side, I need 2 times 3. Reaction of ammonium carbonate with sulfuric acid to produce ammonium sulfate, carbon dioxide gas, and water. So first, write down all the correct formula. Ammonium, okay, just a revision. Ammonium NH4 plus, CO3, 2 minus. So for every carbonate, I need 2 ammonium ions. Therefore, the formula is NH4, 2, CO3. Add it to sulfuric acid. That will give me ammonium sulfate plus carbon dioxide and water. Okay, so let's try balancing. Nitrate, ammonium to ammonium, balance already. Ammonium to ammonium, balance. Sulfate to sulfate, balance. Carbon, carbon. Oxygen, there's 3 here, that's not in sulfate. There's 1, 2, 3 here. So also accounted for. Hydrogen also all here. Yes, balanced equation. F. Reaction of ammonium nitrate with potassium hydroxide to produce potassium nitrate, ammonia gas, and water. Let's try writing this down again. Ammonium nitrate is NH4 plus NO3 with 1 minus, so this is just their formula. NH4 NO3. Okay, write closer a bit. Okay, reacting with potassium hydroxide to give us potassium nitrate, ammonia, and water. Okay, potassium is balanced, ammonium nitrate is balanced. Okay, then everything else is balanced. Yes. Iron 3 hydroxide, so FeOH 3 plus nitric acid HNO3 to give us FeNO3 3 plus water. Okay, now let's look at this. Nitrates over here, I have 3 nitrates, so let's try multiplying it by 3 first. Okay, then I have 3 hydroxide on the left hand side. Iron is balanced already, so let's try balancing the difficult ones. Okay, hydrogen is slightly better than oxygen, so let's try balancing hydrogen first. Okay, there's 6 hydrogen in total. On the left hand side, on the right hand side, I have 2. So let me balance it by putting a 3 here. Okay, let's look at the number of oxygen. So 1, 2, 3, and then 9. 3 plus 9 is 12. 12 oxygen on the right hand side. On the left hand side, I have 1, 2, 3, and then 3 times 3 times 3. So 12. Reaction of potassium and water to produce potassium hydroxide and hydrogen gas. Potassium and water to produce potassium hydroxide and hydrogen gas. So you need to know that hydrogen exists as H2. Okay, potassium is a metal. It exists as just the just write the formula of that particular symbol will do. Okay, very simple. Let's look at the equation. Now again, you can see that on the left hand side, the number of hydrogen must always be even. On the right hand side, this is even and this is odd. So I need to multiply this by 2 to make the number of hydrogen on the right hand side even overall. So let's multiply this by 2 as well. This also by 2. Let's see, am I right now? Yes, then you'll be correct already. Here, reaction of magnesium carbonate and hydrochloric acid to produce magnesium chloride, carbon dioxide, and water. So, magnesium carbonate, Mg2 plus CO3 2 minus, HCl, magnesium chloride, Mg2 plus with Cl minus. So, MgCl2, CO2, H2O. Okay, let's try balancing this. On the right hand side, there's 2 chlorine. Left hand side, put a 2 there. Then it is balanced already. Yes, so that's all. Okay, I forgot to say something that will help you in question Q of your worksheet. So can you take a look at your worksheet that's just given out? So question Q. What am I going to say? Oh yeah. So we've learned about what is the nitrite ion? Okay, we learn nitrate, we learn nitrite. Okay, can you tell me what are the formulas of these two? This is N3 minus, this is NO3 minus. So what is nitrite? Okay, if you see that it ends with high TE, they both means that it is oxygen containing. Okay, but if you end with ITE, there is one less oxygen atom, same charge. So nitrite ion is NO2 minus. Okay, this is the same for all the polyatomic ions. So for example, sulfate is SO4 2 minus. So what is sulfide? And with ITE. Okay, we just remove one oxygen, SO3, have the charge stay the same, 2 minus. So this is sulfide. Okay, so that's all from me. Thank you for watching this tutorial.